Alright, so new video. I'm going to redo this, but I just realized we did all this algebra work, but I forgot to verify it on a graph. So let me go ahead and pull my Desmos out here, right? And when we graph this function, x plus 2, x minus 1 squared, there's what the function looks like. And we do see all our analysis, right? So there's negative 2, and we are below the x-axis, starting at negative 2 and going to infinity. Between negative 2 and 1, we're above. At 1, we're actually equal to 0, which is what we wanted. But then past 3, we're above it. That's basically because of the multiplicity of 2. We could have almost predicted that behavior. So we can see that this graph is actually indicative of what we had, right? So on this part, we're negative. On this part, we're positive. On this part, we're positive. And then at 1 and negative 2 respectively, we are actually equal to 0 where x-intercepts. Okay, so you can literally see, right, the graph with the algebra that we're doing. All right, so the next one's a little bit more challenging, at least it seems that way, because so far, right, in my groundwork and here, right, one side's equal to 0, but here we actually have two functions. There's a cubic function on this side and a linear function on this side. But the step-by-step process is actually still going to be the same. If we were to graph this, there's a couple of ways we can do this one. Is we can actually graph two functions at once. So what I have is some cubic, right? And then over here I have some line. So we're basically trying to figure out, right, when does the cubic graph, when's it above the, let me try to draw a better picture of that. So I have some cubic and I have some line. And so we're basically trying to figure out is when does the cubic graph, when's that above, right, we're greater than the line graph. So again, you can see what I first have to do is find these points of intersections, right, and that's basically the equality. Of course, what we could also do is make this equal to that, move the 5x and the minus 5 over, and we're basically back to doing this. And so now our cubic, right, we're trying to figure out where it crosses the x-axis. So even though we have two different functions, the idea still remains the same. Step 1 is to solve the equality, and look where we're undefined. Well, this one's not undefined, right, because there's no division by 0. To solve it, I will set one side equal to the other. And again, what we've learned, right, to solve this thing, I got to move things over. So we get x cubed minus x squared minus 5x minus 5 equals 0. We have a way to find these zeros, but I think here's an old idea that we haven't seen in a while. We can factor this by grouping, right? I can group the first two together, and be careful, I'm grouping around a minus sign, and group the second two together. Here we have an x squared, x plus 1. Here we have a 5, x plus 1. And so we basically have x plus 1, x squared minus 5 equals 0. So we know that negative 1 is one of our solutions, and the others are going to come from here. So we basically have x squared equals 5, taking the square root, x equals plus or minus 5. So here are the values. I think that's roughly about 2.12-ish. The square root of 4 is 2, so this is a little bit bigger than 2. So now, right, the next step is to take this information and plot it on a number line. So we know we have negative 1. Somewhere down the road we have the square root of negative 5. And somewhere over here we have positive square root of 5. And then somewhere in between there is 0 to give us a little bit of scale. So we have 1, we have 2, we have 3. We basically have 4 intervals that we have to test, right? So here's step 2. And then step 3 is to basically start testing the intervals. So again, this is roughly about negative 2.12. So x equals negative 3 is a good value to plug in. And again, what you want to do is plug it into here and just worry about the values, not the actual, worry about their signs. So when I plug a negative 3 in here, negative 3 plus 1 is negative 2, so we're negative. When I plug a negative 3 in here, I get 9 minus 5 is 4, so it's positive. So a negative times a positive is a negative, so we know that on this this portion here, we're basically negative, right? Or we're solving the less than statement. In the next interval, remember, this is about negative 2 point something, and that's negative 1. So how about we throw a negative 2 in there? Well, a negative 2 plus 1 is a negative 1, so it's negative. And then a negative 2 squared is 4. minus 5 is negative 1, so it's negative. So a negative times a negative is a positive, so we're positive here. So we're solving the greater than. So we can almost start doing the next step. How about I just use 0? 0 plus 1 is 1, so it's positive. 0 squared minus 5 is negative 5, so it's negative. A positive times a negative is negative, so on that portion we're negative. And then last but not least, how about we use a 3, because that's roughly about 2.12. And 3 plus 1 is a positive 4, so it's positive. 3 squared is 9, minus 5 is a positive 4, so we're positive. A positive times a positive is a positive, so we're positive. All right? And so, again, what we're trying to figure out is when are we greater than? So essentially, when are we above? So that seems to be happening here, and it seems to be happening over here. And then we want open circles at these locations because we're not allowed to be equal to. It's a strict inequality. So there's my step 4, if you would. We just did that. And so step 5 is to write our answer in interval notation. So when I look at this, it looks like we're from the square root of negative 5 minus 1, right? That's one interval that I have solutions. And take note of the parentheses I'm using. Union, well, the other one looks like it's from the square root of 5 to infinity, right? And so there would be our solution. So on this stretch, this graph is above that graph, right? Or if we did this, it's above the x-axis. And on this part of the graph, this cubic is above that. So there's two ways to check this answer, and I'm going to go to my Desmos to check that. One is to actually graph, like I did here, graph them individually. So there's the cubic graph, and there's the line graph. Get in there, and you do in fact see, right, that starting right about negative 1, right, the graph actually is, right, the line graph is below the cubic graph, and that's going to occur. There's an intercept occurring there, and that intercept's occurring right just past negative 2. Of course, we know that to be the square root of 5. And then later on, somewhere over here, right around, right, a little bit past 2, I'm going to have to probably come way up, yeah, so right around square root of 5, right, the cubic graph, again, is above that axis. Now, that might be a little bit hard to see because of that, so how about we turn those off, and why don't we just do this strategy where we move everything over and then graph one function and see where it's above and below the x-axis. That might be easier to see visually for us here. And sure enough, there's the graph, and you can see exactly what we said, right? So we know that this is the square root, negative square root of 5, and that's negative 1, and our graph is positive, just like we predicted it, right? And then starting right here at the square root of 5, right, which is just past 2, let me get those 2's in there, right, we can see that the graph again is positive. It's above the x-axis. So we can see that my intervals are actually the intervals of truthness, if you would. All right, so there's basically how we can solve polynomial inequalities. You basically solve when they're equal to. Use those points to break up your number line, essentially your x-axis, and then you start testing intervals, and then the choice is yours. You can actually literally find the values and then determine whether they're positive or negative, or you can just look at their values in terms of their sign. Because that's really what we're after here. When are we, when are we negative? When are we positive? Just make sure you're showing that analysis on your work. I will be satisfied with that. Basically, do what I do, right? That is showing your work. So tell me what you tested. Show me what you evaluated at, right? You can literally do it, or you can just come up with the sign values like I'm doing here. So that's how you're going to show your work for this, and of course your answers, make sure you put them in interval notation. Right? So those are polynomials. So now, right, what happens when we're solving rational inequalities? So let's bring those into the mix, but of course I'll do that in a video coming soon as we transition gears.